What's up, guys? Hello, and how you doing? And welcome to another video. Today we're going to be wishing you all a happy 4th of July, and we're going to be building our very own firework control system. So if you want to see how to do that, let's get started. Okay, guys, so here's a whole bunch of different pieces and parts. We'll go through all of these to get this fire system going. First of all, I got just a large ammo can from Walmart. Okay, we got some wire. I'll put links in the description as usual. We've also got these cool little speaker terminals is basically what I got. Figured these would work great. Got a bunch of terminal blocks here. A bunch of different terminal blocks. These even have like a cool little cover on them. We got one of these cool little volt amp meters. They're real simple. You can get these off eBay. I don't know, I just thought these were cool. You got the flip up top and then the switch. And that's what will basically arm the system, is what we're going to be using for that. Resistors we're going to be using, we'll probably be using the 5-watt single ohm resistor, like we talked about. The main functioning component is going to be a good old relay block with the DF robot Firebeetle, which is a very simplistic, it's a Wi-Fi, Bluetooth, I've used it before on the channel, Arduino compatible little board. So it's a very slick little device. I really enjoy it, and that's another thing I would like to shout out to DF Robot for helping sponsor this video and provide me with one of these. In any case, so let's go ahead and start work on getting the ammo can cut up. I'll peel the sticker off and everything, and we'll get it all cut up and get some holes cut in it so we can get ready to wire everything up. All right. Okay, guys, so what I did was I cut out some little slots in the top of this. Then I put some tape across it just to hide the burrs, and then just kind of took a knife and pierced the tape where it's going to go in. So the idea for this is I'm going to feed the wires inside, and they will go on just like this, where you can press down and insert wires. Okay, and there we are, so to speak. That came out quite nice. I'll still have to cut the hole for the meter and the on switch, but that's coming out pretty darn good. My meter, and I'm gonna put it on ohms, and I'm gonna put it on the beeper. I can check for shorts. So scratch off the paint in an area, maybe touch it to the. Okay, so that one's good. That one's good. And I'm just going to run through these and test them, make sure we didn't scrape anything or get any shorts. Okay, guys, so I got the lid off here. And what I did was I took our relay board and I made these little standoffs for it out of plastic from my 3D printer. So I'll put the link in the description for the files for these, so you can print these. Figured these would be very helpful. Figured I'd put a hole in it so I could screw them down, but I think I'm going to end up just using good old servo tape. I think is what I'm going to be using to put these on. So I'm going to go ahead and get some of this stuff stuck down and begin the wiring. Okay, guys, so here is the top of it. I'll zoom in a little bit so you can see it. So here's all the relays wired. Got the DF Robot Firebeetle on top, and then of course we got all of our basically terminal blocks here that has our deals. So these two wires down here are the main power and grounds. These will be going to the battery that we will then construct and put inside. Okay, guys, so putting the final touches on it, had to end up having to actually drill holes in the top. Actually, I had to drill some holes and put some fasteners. Oop, let's see where you can see it. Put some fasteners in the top to hold everything down because the glue was just, or the sticky tape was just not working. It was just falling apart. I had to create a quick little regulator for the DF Robot because 3 volts was just not enough to power this. So what I did is I just put in a simple simple 7805 volt, 5-volt voltage regulator. Just wired it into the 16 volts right here, and then wired it into the ground here just by lugging it under another lug in here. Got the switches installed, this main switch and the other voltmeter and amp meter, and this little amp meter will actually take the 15-16 amps it's going to be going, so it will register it properly. But the main thing was just so you get a voltage reading so you can keep track of the battery. Since this is going to be a raw pack, I'm not going to put any electronics on it. We have to be mindful of the battery voltage and make sure it doesn't sink too far. Okay guys, so now we're on to the coding and electronics side of the universe. So I've got a schematic here. Now don't be worried, this will be in the description box below it, my GitHub link that's down there, so you can download this PDF and look at it yourself. But basically what we got here, let me see if I can zoom in here. So what we got going on is we've got each one of the little basically speaker like outlet deals that's on here. We got all of this wired up with our positives and negatives. So all the negatives come to a negative terminal block that then goes to the negative of our battery. And for all intents and purposes, I'm using it because Fritzing only has the little LiPo pack battery. So this is our battery pack that we've made, as well as then all the hots, or basically the positives, come through our relay module here, which then controls all the different, all 8 ports that's on it. So got this relay module here. Links are all in the description. The whole bill of materials will be all down in the description. Here's our simple little circuit that we made for our LM7805 voltage regulator to then regulate that down, so that way we can power up our DF Robot little guy here that was also donated by DF Robot. So thanks again to DF Robot. But here's all the main connections that are here. So you can zoom in on this yourself. Like I said, links down in the description. So you basically just wire it up just like this. There were some ports I had to skip because honestly I didn't want to take the time to figure out how to shut off certain dual functionality so that I could just get a digital out. So it kind of skips around a little bit, but you get the gist. And in this I had to use an ESP82 or ESP32 because they didn't have the DF Robots little thing in the Fritzing stuff, so I used the ESP32. Excuse me, I can't talk. But all these hookups is exactly the way it is, and the code even describes it as well. So let's take a look at that real quick. In our coding, we have for ports 1 through 8. So far as the resistor ports go, I've got based on the IO 25, IO 26, 27, 28, and I can show you that here real quick. And you've got the different IO 13, IO 10, IO 7. That corresponds to what you're seeing up here, this IO 25 and IO 26, 27. That's what that corresponds to. So that lets you know where to plug the different ports in at, okay? As well as it also has the ability that you can send it basically serial or ASCII characters, either an ASCII A, ASCII B, ASCII C, whatever you want to do to get different delays. And we'll go through that here in just a second. We're going to be using the Bluetooth to serial, which basically gives us a serial connection on our Bluetooth line. That's how this is being delivered. So you can send it any ASCII character in the Bluetooth app, and then it will actually go to this device and then be interpreted. So all we're doing, we initialize some stuff, and we come in here into a giant if-then is what we do. And so we check to see if the serial is available, and then we set this variable CMD to the Bluetooth read command. So that way we will read any character that gets sent over the Bluetooth to this device. And then we also do a serial write to write the command out for debugging purposes. So we write it out the serial port, so that way when you have this plugged into your computer, you can open up the serial monitor and check to see what you're receiving from the other end. So we look at the command 1. So now we go through and we check what it is. If it's a 1, then we do port 1, essentially. We give it a low. These are all active low, not active high. So we give it a low, and then we delay a certain amount of time. Now, this delay is determined. The default is 1500 milliseconds, so 1.5 seconds, which has worked perfect for me. But just in case if you need to adjust that, maybe on the fly, what I did was on down here, if you go on down, there's another section to this if-then, where if you send it an A, it will change that delay to 500 milliseconds. If you send it a B, it changes it to 1,000, so on and so forth, okay? So that's basically how you can change the what millisecond it is, and it goes all the way up to 3 seconds. So you got anywhere from A to F in 500 millisecond increments. You can adjust how much delay, basically how long it holds the relay shut and keeps the resistor basically hot. So those are the two main things of the software. All you have to do is flash these onto there, which all you got to do is select the Firebeetle ESP32. I've gone through this in the past. You can go to their website, go to that link down below, and look at how to set up the Firebeetle. And then it's just these basic settings: 92.160 for the speed, 80 megahertz for frequency, QIO for this flash mode, and so on and so forth. And of course, you choose what port it's on, and then just do an upload. Again, all this can be downloaded at the link down below. So that's all you got to do. Now, for the app that I am using, I am going to be using this Bluetooth serial controller is what we'll be using for this to work right. You can basically customize this. It works with the Bluetooth to serial. You can customize every button on this and say what you want to call the button, as well as what you want it to send ASCII character wise over the serial connection. Okay guys, so here's a quick rundown on how to set up this little app. To set up these little buttons, I've got Fire 1, 2, 3, 4, 5, 6, 7, and 8. To set these up, you're just going to go into your preferences here. You're going to basically select the name of your buttons, and then it tells you which buttons are which, so you just choose button 1, and then you just give it a name. Like I named it Fire 1, and that's all you got to do, and hit OK, and you just name those first 8 buttons. That's all you got to do. And then for the command, you're going to go down to command, and then you put in that it's going to be ASCII, and then you go on down here, and button 1 is going to be the number 1, button 2 number 2, and so on and so forth, okay, until you get to 8. So that's basically what I did. Now I was also going to set these buttons starting at 10 as A, B, C, D, E, so I can change the timing that I want to. But in testing, it seems like the 1500 milliseconds is going to be fine for me, but that might be something to do just to make it more versatile. Once you've got that done, you have your button set up, it's time to connect it up. So I have our system right here, so we're going to go ahead. Let me move the camera over just a little bit so we can see everything. We're going to go ahead and arm it, which turn the key on to arm it, and then we're going to activate it. So there we are. In fact, let me dim some light here. So there's our 21 volts. Okay, so now we're going to come back over here and take a peek at our configuration. So we're use connect. We're going to find the ESP32 test, okay, and we're going to choose that. Now, I had already previously paired that with my phone, and I'll show you what I mean. Let me go back out of here. Okay, so in my settings under connected devices, you can see that it's already connected up here. I normally would have to go to pair new device. It would scan, and then that ID would come out, ESP test would come up, and then once you pair it, you should see it in currently connected devices. Once that's paired, you're good to go. Okay, now we have the app, and then you can choose that connect and choose it, which we're already connected. I don't know if you can see that in the upper corner. If I can zoom in, if it's going to be, yeah, no, you'll be able to see it. It says connected. Now when we press the buttons, you should, I don't know if the microphone will pick up the click, but you should see the amperage go up, because this is measuring overall amperage of the ESP 8266 and any LEDs or anything, and as well as the relay coils should show up here. So if I press one, there it is. So there is one, and so on and so forth. So I can press them. All right, so that's basically it for setting up the app. So software-wise, we should be good to go. We got it flashed. We got the circuit hooked up the way that we're supposed to, so we should be good to go. So we'll put the final touches on it and we'll be ready. Okay guys, so now it's time to build the battery pack that we're going to be working with. Now what we're going to be doing is I ordered these little holders. These things are actually kind of nice. The idea here is we're going to do basically like a 16 to 18 volt pack, somewhere around in there. So it's going to be a 5S 4P, meaning that we're going to have 5 batteries in series, okay, 5 batteries in series, and then 4 of those packs in parallel, okay, so that'll give us about 10 amp hours. Now, doing the math and all the magic number stuff should be about 1200 shots-ish is what we should get out of this battery pack. These are basically the good old Samsung cells, is what these are. So we've got the positive terminal and the negative terminal, and we're basically just going to build this. Now, before I get started, like I tell everyone, when dealing with batteries, I used to build batteries way back in the day, and when you're dealing with batteries, and especially open packs, and you're soldering and you're welding, you're doing all this stuff, you definitely don't want anything metallic coming in contact with the battery, okay? Because these things, remember, are charged, and when they're charged, they can discharge, and there is no off switch. They will discharge till they stop, okay? So you do not want to get a ring or jewelry or something across the battery terminals, because it probably won't electrocute you. 18 volts is not enough to electrocute you, but it will short across your ring or your piece of jewelry, and it can literally melt your skin off because it's going to get hot. Not good whatsoever. So always take safety precautions. Wear gloves if you need to, or do like I did, electrically tape your ring if you can't get your ring off, or rings, whatever. My watch, I will go ahead and take my watch off. So what I'm going to do is I'm going to go ahead and load these up. Positive here, then negative will go down. Batteries in series add, at least voltage wise, they add. So we've got 3.7 plus 3.7 plus 2.7 plus 2.7 plus 3.7. See, is what we're doing. So we're raising the voltage by putting these together and putting them in series. So now I'm going to go ahead and I'm going to make 3 more rows of these and get the rest of these in here. All right. So what we're going to do to weld it, we're going to use these. I got these with my battery welder. If you want to see the review of the welder that I'm using, you can check it out on my channel. I may leave a link or a card or something. But in any case, I'm going to be using a Sunco battery welder. And I've got some pure nickel tabs. You want to use pure nickel. You don't want to use the nickel plated steel. Trust me, having pure nickel does the trick much better. See these little holder tabs? These little tabs that hold the cell? This can fit right in between them. And that's exactly what I want to be able to weld it together. Okay guys, so I've sitting here, got my welder set up right here. So this is the Sunco 709A battery welder that I got a while back. Thank you very much, Sunco, for donating that to me. They basically sent that to me. There's a video that's all about the review of this, so if you want to go check that out, you totally can, no problem. Let's go ahead and get this under here and get some welding going. Okay, now with a good meter, I'm going to check how we did. So I'm going to turn the pack over on its side, and then we're going to check the polarity, and we'll check, we should have pretty decent amount of voltage here. So we got the negative is going to be on this side, and the positive is going to be on this side. So there we are, about 17.59, which, yeah, it's going to be a little less than 18 because of it being half charged. I always ship these half charged. So that's pretty good. So our welding is working. So I'm going to go ahead and weld up all the series connections, and we'll do the parallel connections last. Okay, and then there's our pack. So we've got our positive that we can, positive tab we can solder onto, and we got our negative tab that we can solder onto. Okay guys, so we've got the box 3D printed. So this is our box that we got going. So this should fit on right there. I've gone ahead and installed the battery terminals we will be using. So what we're going to have to do is take our raw pack that's here, and we're going to have to solder a couple of wires onto it. So one for the positive, one for the negative side of the battery, and then put those in on the terminals, as well as solder our balancing lead. Another little piece of equipment that I'm going to be using is one of these cool little voltage, low voltage detection circuits. Link down in the description. But what these do is you basically can take your balance leads and plug them onto it, and it will measure the voltage across each cell, and it will let out a squealing sound on these little squealers that are up here, basically piezo speakers, when it falls below a certain value, and that value is programmable. It has a one button ability to program it, and then that way if a cell goes to under voltage or basically gets close to under voltage, I won't actually let it go there. I'll set it a little bit above that, but we'll set that up to where it will squeal. We'll probably mount these up in the top of this box. So that's what we're going to do for our safety. And now we'll get ready for soldering. Okay guys, so we're back. So I got these all soldered on. So here's all of our cell balancers. Since I have 4 parallel stacks of 5 series cells, I have to have all 4 balancers, okay, connected up. Woo, those things are loud. So now let me turn off some light here so you guys can see what it's telling you. But it scrolls through each cell and tells you the voltage. Now you click this little button and it has its own little like range where you can go through what voltage you want it to alarm at. What's up guys? Okay, so we're at the giant tent here behind me. I don't know if you can see that. It's huge. I'm here with my son, who's over there, and we're gonna pick up something to test our system out with. Okay, so trying to find some that are cheap is interesting. What is this? That's only $14. Sold. Grab that. Let's see another one that's only 20 bucks. Oh yeah. Let's see, we're gonna get a big one here. This is not too bad. Bigger than yours. I spy a Raspberry Pi. Okay, so I think, you know, we're pulling a pretty good thing of it. What do you think? I'd say that's probably enough for the first night at least. Okay, so what I'm doing to make up our little wires here is I've got just some of our wire material. I'm crimping butt tap connectors that are on here, and it's actually working out pretty well. So we just basically put this in there and put one end of the lead in. We crimp her down. Okay, and I basically do the same thing to the other side. I basically add to it a little clip, so that way I can clip the fuse to it. So clip that on, and then basically just take the back and I just kind of twist it up just a little bit. So okay guys, so here's our little device. So what we're gonna do is we're gonna be hooking this all up. So what I will probably do, we got 8 of our sensors. Now, I did have one bad relay on that relay card, so I won't be able to hook up port number 3, but you'll get the gist. I got 8, you can take a pan of it. I got 8 different, well, they're not all different, some are the same, but 8 different things to fire, and we're gonna sit back, relax, and fire them from our phone. So if you wanna come over here and get a close-up, you can see I'm gonna put the fuse on top of the resistor and then just clip it in place, okay? So that's all we gotta do. So, okay, so I'm gonna go ahead and arm the system. So if you wanna look at it, I'll arm it, and then we'll fire it up. So I got good voltage, and I'm gonna go ahead and connect it up here. And now I'm connected. We should be good to go. All right, guys, so we're sitting down. I got our screen up here. So let's go ahead and fire one off, shall we? And there it goes. There's another one. Another one. He lit another one. This is so cool. Well, I'd say that's it.
Holy!
I'd say that was worth it. That worked marvelously. Okay guys, well I hope that you enjoyed this video. Hopefully you enjoyed the fireworks show there at the end. This was a really fun project to build, very interesting, took a lot of different pieces. I definitely want to give a big shout out and a big thank you to our friends over at DF Robot. Go check them out if you haven't already. They helped in sponsoring this video and supplying the brain for this device. The Firebeetle was sponsored by them, so definitely check them out. And also check down below, I've got some coupon codes for you guys. Some for first-time buyers, you get some money off, so definitely check that out down below. Also, definitely like, subscribe, and share, so that way this video gets out to as many people, because I know there's going to be some firework people that are going to love this way of doing it, since it allows you to use the same fuse, the same match basically over and over and over. So guys, thank you so much for all of your support. Also check out my Patreon and check out new shirts that we got. We got these cool engineered shirts that we got going on, so definitely check those out. Link will be down in the description, so if you want one of these, it helps out the channel, as well as you get to wear some stuff that helps support the channel and show off your engineering pride. It's going to be more shirts like this. There'll be ones for each individual discipline of engineering, so it ought to be a lot of fun. So definitely check that out down below. We're adding stuff all the time, as well as make sure that you check out the Patreon, because you get some exclusives. I'm just finishing up doing the coding, and we'll move on to doing microelectronics basics and basically fundamentals for engineering, for electrical engineering. So it ought to be really cool, and that is only exclusive for my Patreon subscribers. Also, check out, I will be doing a giveaway coming, let's see, not this Monday, but next Monday, we'll be doing a giveaway for one of the Firebeetles that DF Robot has given us, so graciously given us. So, guys, thank you very much. Have a wonderful and safe 4th of July holiday, and we will see you next time.